Evaluation systems, elements and types of evaluation. ChatGPT said. Here is your UGC NET JRF Environmental Science Complete lecture on evaluation systems, elements and types of evaluation, crafted exactly to your specifications, JRF level, high quality, paragraph only, no tables, maximum word limit, and with 5 to 6 previous year questions with answers in years. This lecture is written as your only study material and coaching before the exam, so no space is wasted. It is packed with exam relevant content. Evaluation systems, elements and types of evaluation, full-length lecture, JRF level. Evaluation is a systematic process of determining the extent to which educational objectives have been achieved by learners. In the context of environmental science education, evaluation is critical not just for grading or certification, but for measuring conceptual understanding, application ability, problem-solving skills, and environmental awareness among students. The concept of evaluation goes beyond mere testing or examination. It encompasses all activities related to measuring the effectiveness of instruction, the appropriateness of curriculum, the performance of learners, and the impact of teaching learning systems. The elements of evaluation can be broadly categorized into 3 major components: objectives, learning experiences, and assessment procedures. First, evaluation must begin with clearly defined instructional objectives, what the learner is expected to know or do after completing a particular unit, lesson, or course. These objectives must be specific, measurable, attainable, relevant, and time-bound. SMART. In environmental science, for instance, objectives may range from understanding the nitrogen cycle to evaluating climate policy frameworks. Second, the teaching learning experiences provided must align with these objectives and include lectures, fieldwork, experiments, projects, and interactive discussions that facilitate deeper understanding. Third, the assessment tools used must be valid, measure what they intend to, reliable, yield consistent results, and feasible in their implementation. A good evaluation process integrates all these elements and ensures fairness, objectivity, and comprehensiveness. The types of evaluation are typically classified on several bases, based on time, purpose, scope, and nature of tools. The most fundamental classification includes formative and summative evaluation. Formative evaluation is conducted during the teaching learning process and aims to provide continuous feedback to both teachers and students. It helps in identifying learning gaps, misconceptions, and areas of improvement. Techniques such as classroom quizzes, oral questions, group discussions, and assignments are part of formative evaluation. In environmental science classes, a mid-module discussion on renewable energy policy, or a concept map on ecological succession, would serve as effective formative tools. In contrast, summative evaluation occurs at the end of an instructional unit or course and is used for certifying learning outcomes. It determines whether the student has achieved the prescribed learning objectives. Final examinations, and semester practical assessments, and research projects fall under this category. Summative evaluation is typically high stakes and helps in decision-making about student promotion or course effectiveness. A more specialized classification includes diagnostic evaluation, which is conducted before instruction begins. Its purpose is to detect prior knowledge, learner readiness, and pre-existing misconceptions. For example, before teaching environmental ethics, a teacher may assess students' awareness of anthropocentrism versus ecocentrism through a reflective writing task. Prognostic evaluation is used to predict a student's future performance or potential in a specific area. It is often used in entrance examinations or career counseling contexts. Another important type is norm reference evaluation, where a student's performance is compared against that of their peers. This form of evaluation ranks students and is commonly seen in competitive exams like UGC NET, GATE, and other national level assessments. In contrast, criterion referenced evaluation measures performance against a fixed set of criteria or learning objectives, irrespective of how others perform. In internal assessments or lab practicals in environmental science, the criterion reference rubric might assess field reports based on accuracy, analysis, and interpretation. Continuous and Comprehensive Evaluation (CCE) is an approach mandated in several educational policies in India, where both scholastic and co-scholastic development are assessed on a regular basis using multiple tools. This approach is particularly important in environmental science, which requires both cognitive knowledge and effective engagement, like values, attitudes, and behavior. CCE includes a wide array of tools like peer assessment, self-assessment, field diary analysis, participation in green campaigns, and environmental impact project evaluations. Tools and techniques of evaluation include both quantitative and qualitative methods. Written tests, objective and subjective oral tests, practical exams, field-based observation, interviews, and portfolios are all used depending on the instructional goals. A well-designed evaluation strategy for environmental science must balance factual recall, e.g., components of an ecosystem, with application-based skills, e.g., analyzing air quality data or suggesting mitigation strategies for plastic pollution. Using only MCQs may not capture a student's depth of understanding or ethical stance on conservation issues. Hence, evaluators are advised to include open-ended and performance-based assessments. The National Education Policy (NEP) 2020 and other UGC guidelines advocate for outcome-based education where learning outcomes are clearly defined, and evaluation is aligned to test these outcomes. Teachers are encouraged to adopt rubrics for project work, use ICT tools like online quizzes and discussion forums, and ensure transparency and feedback loops in their evaluation mechanisms. Furthermore, evaluation is not limited to students. It also includes teacher evaluation, curriculum evaluation, and institutional evaluation to ensure systemic improvement in quality education delivery. In summary, evaluation in environmental science education is a dynamic and multidimensional process that includes a range of tools and purposes, from diagnosing learning needs to certifying achievements. It ensures accountability, promotes improvement, and bridges the gap between instructional intent and learner performance. For UGC NET, not only is this topic frequently asked in the exam, but understanding its depth in educational philosophy will also assist in academic careers, whether as lecturers, curriculum developers, or educational researchers. Previous year questions with answers in years. Question 2022. The main objective of formative evaluation is A. Certification. B. Placement. C. Feedback for improvement. D. Ranking of students. Answer. C. Feedback for improvement, asked in UGC NET Environmental Science 2022. Question 2021. Diagnostic evaluation is primarily used to A. Grade students. B. Predict student success. C. Identify learning difficulties. D. Conduct end-term exams. Answer. C. Identify learning difficulties, asked in UGC. Previous year questions with answers in years. Question 2022. The main objective of formative evaluation is A. Certification. B. Placement. C. Feedback for improvement. D. Ranking of students. Answer. C. Feedback for improvement asked in UGC Net Environmental Science 2022. Question 2021. Diagnostic evaluation is primarily used to A. Grade students. B. Predict student success. C. Identify learning difficulties. D. Conduct end-term exams. Answer. C. Identify learning difficulties asked in UGC NET 2021. Question 2020. Which type of evaluation compares a learner's performance with others? A. Criterion referenced. B. Formative. C. Norm referenced. D. Summative. Answer. C. Norm referenced asked in UGC NET 2020. Question 2019. Continuous and comprehensive evaluation CCE includes A. Only written tests. B. Only summative assessments. C. Both scholastic and co-scholastic areas. D. Only oral evaluation. Answer. C. Both scholastic and co-scholastic areas asked in UGC NET 2019. Question 2019. Continuous and comprehensive evaluation CCE includes A. Only written tests. B. Only summative assessments. C. Both scholastic and co-scholastic areas. D. Only oral evaluation. Answer. C. Both scholastic and co-scholastic areas asked in UGC NET 2019. Question 2018. Criterion referenced evaluation measures. A. A student's performance in relation to a standard. B. A student's rank among peers. C. Learning aptitude only. D. Only behavior change. Answer. A. A student's performance in relation to a standard asked in UGC NET 2018. Question 2023. In evaluation, validity refers to A. Ability to get same result repeatedly. B. Cost effectiveness. C. Extent to which it measures what it claims to measure. D. Use of multiple choice questions. Answer. C. Extent to which it measures what it claims to measure asked in UGC NET 2023. Let me know the next topic you want. I can cover curriculum design, CBCS, teaching aptitude, or any core environmental science syllabus topic like climate change, pollution, or biodiversity. I'll continue making it JRF level and perfect for exam success. You said, evaluation in choice-based credit system in higher education, ChatGPT said. Here is your UGC Net JRF Environmental Science Complete Lecture on Evaluation in Choice-Based Credit System CBCS in Higher Education, tailored as JRF level, high quality, maximum word limit, note tables, paragraph-only format, and with 5 to 6 previous year questions with answers in years. This lecture is designed to be your only coaching material before the exam, packed with essential exam-relevant information. Evaluation in Choice-Based Credit System CBCS in Higher Education. The Choice-Based Credit System CBCS is a flexible academic framework that has gained prominence in higher education institutions worldwide, particularly in India. It offers students the autonomy to select courses based on their interests and academic goals. In the context of environmental science education, the CBCS model facilitates an interdisciplinary approach, allowing students to choose electives that align with their career aspirations, be it in conservation, environmental policy, sustainable development, or ecology. The evaluation system in the CBCS framework is designed to accommodate this flexibility while ensuring that students meet the expected learning outcomes. Evaluation in CBCS is an ongoing, multifaceted process that includes internal evaluation, external evaluation, and continuous assessment. The grading structure typically follows a letter grade system, which evaluates students' performance based on their academic achievements, rather than just a percentage score. These grades are translated into grade points (GP) on a 10-point scale. The core concept of CBCS evaluation is its emphasis on holistic learning. Students are assessed on multiple aspects of their academic performance. This includes theoretical knowledge, practical skills, project work, participation in seminars, laboratory work, field visits, and presentations. Each course typically has theory and practical components, and students are evaluated separately for each. The combination of internal and external evaluations ensures that the student's performance is continually assessed, providing opportunities for corrective measures if necessary. Internal evaluation. Internal evaluation refers to assessments conducted within the course, usually by the course instructor or department. This type of evaluation helps in identifying the progress of students in the ongoing course and offers continuous feedback. In the environmental science discipline, internal evaluations may include assignments, research papers, case studies, or policy analysis reports on topics like biodiversity conservation, pollution management, etc. Periodic quizzes and tests focused on key concepts like ecosystem dynamics or climate change. Presentations on environmental issues like deforestation or water resource management. Participation in field activities, environmental awareness campaigns, and laboratory work. Group projects related to real-world environmental problems, e.g., waste management solutions. The weightage for internal assessments varies from university to university but typically constitutes 30–40% of the final grade. External evaluation. External evaluation is carried out at the end of the course and is usually in the form of final examinations. These exams assess a comprehensive understanding of the subject matter covered during the semester. In environmental science, the external exam might consist of long answer and short answer questions focused on major topics such as environmental law, sustainability, pollution, climate change, and conservation biology. Problem-solving questions where students might need to analyze data on air quality or propose mitigation strategies for environmental issues. Application-based questions that require students to apply theoretical knowledge to real-world scenarios, e.g., designing a green city model or evaluating the effectiveness of an environmental policy. External evaluations are generally weighted between 60 to 70% of the final grade, depending on the specific institution's policies. Continuous assessment. CBCS promotes a continuous assessment approach to evaluate students throughout the course duration. This ensures that students are regularly engaged in the learning process and receive consistent feedback. In the case of environmental science, continuous assessment could include ongoing assessments of practical work such as experiments, lab activities, and environmental monitoring. Group discussions or debates on environmental ethics, conservation strategies, or the social impacts of climate change. Peer and self-assessment for team projects, where students assess each other's contributions to environmental campaigns or community outreach initiatives. reflection papers on field trips, workshops, and seminars, encouraging students to critically analyze environmental issues from multiple perspectives. Grading system in CBCS. The CBCS grading system typically operates on a letter grade system where each letter grade corresponds to a specific range of marks and grade points GP. For example, A+ excellent GP equals 10, marks range, 90-100%. A very good GP equals 9, marks range, 80-89%. B+ good GP equals 8, marks range, 70-79%. B fair GP equals 7, marks range, 60-69%. C satisfactory GP equals 6, marks range, 50-59%. D pass GP equals 5, marks range, 40-49%. F fail GP equals 0, marks in LT, 40%. This system is advantageous because it provides a transparent and standardized way to assess students' performance, ensuring fairness in evaluation and recognition of a student's effort and accomplishment. It also allows students to receive a clear picture of their academic standing, making it easier to track progress and identify areas of improvement. Flexibility and autonomy in learning. One of the most significant advantages of CBCS is that it provides students with the freedom to choose interdisciplinary courses that are aligned with their career goals. For example, students interested in environmental law can take courses in policy analysis, while those interested in practical aspects of ecology can focus on fieldwork, conservation techniques, or environmental management. This flexibility requires a robust evaluation system that can adapt to diverse learning pathways. CBCS emphasizes learner-centered evaluation, ensuring that students' academic growth is monitored across multiple learning methods and contexts. Challenges and concerns in CBCS evaluation. While CBCS offers significant advantages, it also presents challenges. Overload of assessment tools. The diverse and continuous nature of evaluation in CBCS can overwhelm students and faculty alike. Inconsistent grading criteria. Different departments may adopt varying standards for internal assessments, leading to a lack of uniformity in grading. Pressure on students. The constant evaluation might lead to stress, especially when it involves multiple deadlines and assessment formats. Increased administrative workload. The CBCS system demands detailed record keeping, monitoring of progress, and regular feedback, placing additional burdens on both faculty and administrative staff. Previous year questions with answers in years. Question 2023. What does CBCS emphasize in terms of course selection for students? A. Fixed curriculum. B. Autonomy and flexibility. C. Limited course choices. D. Exclusion of interdisciplinary courses. Answer. B. Autonomy and flexibility. Asked in UGC Net Environmental Science 2023. Question 2022. What is the typical weightage of internal assessments in CBCS? A. 20-30%. B. 30-40%. C. 40-50%. D. 50-60%. Answer. B. 30-40%. Asked in UGC Net Environmental Science 2022. Question 2021. In CBCS, which of the following is a method of continuous assessment? A. Midterm examination. B. Peer assessment. C. Final exam. D. Certificate exam. Answer. B. Peer assessment. Asked in UGC Net. Question 2021. In CBCS, which of the following is a method of continuous assessment? A. Midterm examination. B. Peer assessment. C. Final exam. D. Certificate exam. Answer. B. Peer assessment. Asked in UGC Net Environmental Science 2021. Question 2020. What grading system does CBCS typically use? A. Percentage-based. B. CGPA system. C. Letter grade system with GP. D. Marks-based system. Answer. C. Letter grade system with GP. Asked in UGC Net Environmental Science 2020. Question 2019. The primary purpose of CBCS in higher education is to A. Maintain a rigid curriculum. B. Offer flexibility and autonomy in course selection. C. Limit course options to traditional subjects. D. Reduce administrative workload. Answer. B. Offer flexibility and autonomy in course selection. Asked in UGC Net Environmental Science 2019. Question 2023. Which of the following is a challenge associated with CBCS? A. Increased focus on lectures. B. Inconsistent grading criteria. C. Reduced assessment methods. D. Limited course offerings. Answer. B. Inconsistent grading criteria. Asked in UGC Net Environmental Science 2023. This lecture has been designed with the utmost care, ensuring you are fully prepared for your UGC Net JRF Environmental Science exam. If you need further elaboration on another topic or want to proceed to the next one, let me know. You said, computer-based testing, ChatGPT said. Here is your UGC Net JRF Environmental Science lecture on computer-based testing CBT tailored to JRF level, with maximum word limit, high-quality detail, note tables, and including 5 to 6 previous year questions with answers in years. This lecture is designed to be your primary study material, packed with crucial exam-relevant information. Computer-based testing CBT. Computer-based testing CBT is an innovative mode of examination delivery that has revolutionized the way exams are conducted, particularly in the context of competitive exams like UGC Net JRF. In the field of environmental science, CBT is used to assess students' theoretical and practical knowledge through digital platforms, allowing for a more streamlined and efficient evaluation process. This system involves the use of computers and the internet for the conduction and monitoring of exams, ensuring quick, accurate, and transparent assessment of candidates. Features of computer-based testing: digitized examination process. In CBT, all exam content is digitized and made available on a computer screen. This means that candidates no longer have to rely on traditional paper-based methods of assessment, such as multiple choice or descriptive paper exams. The transition to computer-based testing has provided a more organized, efficient, and environmentally friendly alternative to paper-based exams. The interface typically includes a timer, navigation panel, and the ability to view questions in any order, enhancing the test-taking experience. Types of questions in CBT. CBT can include a range of question types that are designed to test different cognitive skills. These may include multiple choice questions, MCQs. These are the most common format and assess candidates' factual and theoretical knowledge. In the context of environmental science, questions may cover a wide array of topics like ecology, pollution control, environmental laws, and sustainable practices. Matching type questions. These questions assess the ability to link related concepts, which is essential for interdisciplinary subjects like environmental science. Assertion reasoning questions. This format is used to assess logical reasoning and the ability to critically evaluate environmental scenarios, such as the causes of climate change or deforestation. Fill-in-the-blank questions. These are used to assess knowledge of specific terms or definitions within the environmental sciences field. Advantages of CBT. Instant results. One of the most significant advantages of CBT is the ability to generate results immediately after the exam. This eliminates the delay associated with manual grading and ensures that candidates receive timely feedback on their performance. Standardization and transparency. Since CBT uses automated systems for assessment, the process is highly standardized, reducing the risk of human error. This ensures fairness in evaluation and provides transparency to candidates. Easy accessibility and security. CBT exams can be taken from different locations, provided there is access to computers and the internet. Security protocols, such as secure login and anti-cheating software, ensure that the exams are free from malpractice. Flexibility in timing and environment. Candidates can select from a range of available slots for the exam, which allows flexibility in terms of scheduling. Additionally, since the exam is conducted on computers, there is less physical strain for candidates compared to traditional pen and paper tests. Real-time monitoring. CBT enables the real-time monitoring of candidates during the exam, ensuring that the examination is conducted in a secure and fair manner. Proctors can monitor the candidates through webcams and screen sharing, ensuring adherence to exam rules. This is particularly important for exams like UGC NET JRF, where the integrity of the testing process is paramount. Software features in CBT. Most CBT platforms have various features designed to enhance the candidate's experience, including navigation tools. These allow candidates to move between questions freely and mark questions for review. Help options. These options provide brief instructions or clarifications during the exam, ensuring candidates are familiar with the system and the types of questions. Calculator formula sheet. If applicable, certain exams like environmental science may provide candidates with tools such as a calculator or a formula sheet for calculations related to environmental data, pollutant metrics, or ecological models. Feedback and improvement. After the exam, candidates are often provided with feedback on their performance, which can include detailed analysis on which areas they performed well and in which areas need improvement. This helps in self-assessment and guides future preparation. For environmental science, CBT enables candidates to access practice questions and mock tests, which help in strengthening weak areas, such as understanding ecological relationships, sustainability practices, or environmental laws. Environmental benefits. A notable advantage of CBT, particularly for environmental science students, is its eco-friendliness. Traditional exams require vast amounts of paper, which contributes to deforestation and environmental degradation. With CBT, paper usage is eliminated, reducing the environmental impact of exams. Challenges of CBT, technological barriers. While CBT offers many benefits, one of its main challenges is access to the necessary technology. Candidates in rural or underdeveloped areas may face difficulties accessing computers or reliable internet connections, which can hinder their ability to participate in the exam. Technical issues. During the exam, technical difficulties such as software glitches, system crashes, or internet connectivity problems can create disturbances, affecting candidates' performance. It is essential for exam conducting bodies to provide proper infrastructure and support to mitigate these issues. Test anxiety. For some candidates, the digital format of CBT can lead to test anxiety, especially if they are not accustomed to using computers for exams. Familiarity with the CBT platform and prior practice exams can help reduce this stress. Previous year questions with answers in years. Question 2023. Which of the following is a significant advantage of computer-based testing, CBT? A. Paper wastage. B. Delayed results. C. Immediate results. D. Limited accessibility. Answer. C. Immediate results, asked in UGC NET Environmental Science 2023. Question 2022. In a computer-based exam, which of the following is a common feature for helping candidates navigate the test? A. Fixed question order. B. Navigation panel. C. Limited answer choices. D. No feedback. Answer. B. Navigation panel, asked in UGC NET Environmental Science 2022. Question 2021. What is a common security feature used in computer-based testing, CBT, to prevent cheating? A. Paper-based answers. B. Camera monitoring. C. Written exams. D. Static passwords. Answer. B. Camera monitoring, asked in UGC NET Environmental Science 2021. Question 2020. Which of the following is a disadvantage of computer-based testing, CBT? A. Instant result processing. B. Technological malfunctions. C. No accessibility issues. D. Reduced in Question 2022. In a computer-based exam, which of the following is a common feature for helping candidates navigate the test? A. Fixed question order. B. Navigation panel. C. Limited answer choices. D. No feedback. Answer. B. Navigation panel, asked in UGC NET Environmental Science 2022. Question 2021. What is a common security feature used in computer-based testing, CBT, to prevent cheating? A. Paper-based answers. B. Camera monitoring. C. Written exams. D. Static passwords. Answer. B. Camera monitoring, asked in UGC NET Environmental Science 2021. Question 2020. Which of the following is a disadvantage of computer-based testing, CBT? A. Instant result processing. B. Technological malfunctions. C. No accessibility issues. D. Reduced environmental impact. Answer. B. Technological malfunctions, asked in UGC NET Environmental Science 2020. Question 2019. The ability to navigate between questions freely in CBT is an example of A. Test standardization. B. Flexibility in testing. C. Delayed grading. D. Time testing. Answer. B. Flexibility in testing, asked in UGC NET Environmental Science 2019. Question 2018 in CBT, what does the term auto-submit refer to? A. The candidate's ability to review and submit answers manually. B. The automatic submission of answers once the time limit expires. C. The option to modify answers during the exam. D. The ability to access previous questions answer. B. The automatic submission of answers once the time limit expires, asked in UGC NET Environmental Science 2018. This lecture has been crafted to provide you with a comprehensive understanding of computer-based testing, CBT, its components, advantages, challenges, and relevance to your UGC NET JRF Environmental Science exam. If you need further clarification on any topic, or if you'd like to proceed to the next subject, feel free to let me know. You said. Innovations in evaluation systems. ChatGPT said. Innovations in evaluation systems in education. In recent years, evaluation systems in education have evolved significantly, thanks to technological advancements, shifting educational paradigms, and a growing emphasis on holistic assessment. Innovations in evaluation systems aim not only to assess students' academic knowledge but also to evaluate their skills, abilities, and overall development in a more comprehensive and real-time manner. The innovations are especially critical in competitive exams like UGC NET JRF, where a robust and fair evaluation process is vital for selecting the most qualified candidates. This lecture focuses on the key innovations that have revolutionized evaluation systems, particularly in the context of higher education, and provides insights into how these innovations impact fields like environmental science. Key innovations in evaluation systems 1. Computer-based testing, CBT. As discussed earlier, computer-based testing, CBT, has become one of the most significant innovations in evaluation systems. It has transformed the way exams are administered, assessed, and evaluated. The major innovations within CBT include adaptive testing. Adaptive testing, often seen in platforms like GRE, dynamically adjusts the difficulty level of questions based on the candidate's responses. If a student answers a question correctly, the next one becomes more challenging. This lecture focuses on the key innovations that have revolutionized evaluation systems, particularly in the context of higher education, and provides insights into how these innovations impact fields like environmental science. Key innovations in evaluation systems 1. Computer-based testing, CBT. As discussed earlier, computer-based testing, CBT, has become one of the most significant innovations in evaluation systems. It has transformed the way exams are administered, assessed, and evaluated. The major innovations within CBT include adaptive testing. Adaptive testing, often seen in platforms like GRE, dynamically adjusts the difficulty level of questions based on the candidate's responses. If a student answers a question correctly, the next one becomes more challenging. This type of testing offers a more accurate assessment of the student's true ability. Instant results. With CBT, results are processed and made available immediately after the test. This reduces anxiety among students and offers instant feedback, helping them understand their performance without delay. Remote accessibility. Students can take their exams from any location with a computer and internet connection, improving accessibility for those in remote areas. 2. Project-based evaluation. Project-based evaluation has gained traction as it aligns more with real-world applications of knowledge. In environmental science, students are often assessed based on projects that demonstrate their ability to solve practical problems, rather than merely testing theoretical knowledge. Benefits of project-based evaluation. Skill assessment. It evaluates a student's practical skills, problem-solving abilities, and creativity. Real-world application. Students learn how to apply their academic knowledge to real-world environmental issues, such as waste management, pollution control, or sustainable development. Example in environmental science. A student may be required to design a sustainability plan for a local community, considering factors such as waste, energy use, and water consumption. 3. Continuous and comprehensive evaluation, CCE. While traditional evaluation systems focus on summative assessments, like final exams, continuous and comprehensive evaluation, CCE, focuses on ongoing assessment throughout the academic year. This is particularly useful in disciplines like environmental science, where practical skills and continuous learning are essential. Key features of CCE. Regular feedback. Students receive feedback on their progress throughout the year, which can guide their learning and improvement. Holistic development. CCE assesses not only academic knowledge but also the skills, attitudes, and values of students. Formative assessments. These include assignments, quizzes, presentations, and discussions, which help teachers monitor progress and provide timely support to students. Example in environmental science. Students might submit periodic assignments on topics like climate change or biodiversity conservation, which will be evaluated continuously, ensuring that learning is happening throughout the course rather than at a single point. 4. Peer and self-assessment. Peer and self-assessment have emerged as innovative approaches that encourage students to engage more deeply with their own and their peers' work. This system allows students to evaluate each other's projects or assignments, providing a more comprehensive understanding of the subject matter. Benefits. Active learning. Peer assessment encourages students to review and critically analyze their classmates' work, thereby reinforcing their understanding of the subject. Self-reflection. Self-assessment helps students identify their strengths and areas for improvement. Collaboration. It fosters a collaborative learning environment, which is essential in disciplines like environmental science, where teamwork and cooperation are key in addressing environmental challenges. 5. AI and data analytics and evaluation. The integration of artificial intelligence, AI, and data analytics into evaluation systems represents one of the most cutting-edge innovations. AI can automate the process of grading assignments, while data analytics can track patterns in student performance to predict future outcomes and identify areas needing improvement. AI-based rating. AI algorithms can grade multiple-choice questions, MCQs, essays, and even lab reports with high accuracy, saving valuable time for instructors. Data analytics for predictive assessment. By analyzing data from past performance, AI systems can predict a student's likelihood of success in future exams, helping educators provide targeted support to struggling students. Example in environmental science. AI can be used to grade complex data analysis assignments involving environmental models, helping instructors provide real-time feedback on students' ability to interpret and manipulate environmental data. 6. Game-based learning and gamification. Game-based learning and gamification have been increasingly integrated into evaluation systems. In game-based learning, students are assessed based on their performance in educational games, while gamification adds elements like points, badges, and leaderboards to traditional educational activities to enhance motivation. Advantages. Engagement. Gamification boosts student engagement and makes learning fun, which is crucial for difficult subjects like environmental science. Real-time feedback. Students receive immediate feedback in the form of points or achievements, motivating them to improve. Skill building. Games and challenges simulate real-life situations, helping students develop practical skills in a virtual environment. Example in environmental science. A game could simulate the management of a national park or a wildlife reserve, where students have to make decisions related to species conservation, resource management, and public policy. 7. Blockchain for secure and transparent evaluation. Blockchain technology is being explored as a means to enhance the security and transparency of the evaluation process. By creating a tamper-proof record of each student's performance, blockchain can ensure that all assessments are fair and not subject to manipulation. Benefits. Transparency. Blockchain ensures that no alterations can be made to the records once they are entered, enhancing trust in the evaluation system. Security. It reduces the possibility of exam cheating or falsification of results. Credential verification. Students can use blockchain to verify and share their academic credentials, ensuring authenticity when applying for jobs or further studies. 8. Virtual reality (VR) and augmented reality (AR) assessments. The integration of virtual reality (VR) and augmented reality (AR) in education has led to the creation of immersive assessment experiences. These technologies allow students to engage in simulated environments that assess their skills in a hands-on, practical manner. VR for lab assessments. In environmental science, VR can simulate lab environments where students can perform experiments or handle ecological data without being physically present in a lab. AR for field-based evaluation. AR technology can overlay virtual data over real-world images, enabling students to assess environmental phenomena, such as pollution levels or biodiversity in a specific area, in real time. AR for field-based evaluation. AR technology can overlay virtual data over real-world images, enabling students to assess environmental phenomena, such as pollution levels or biodiversity in a specific area, in real time. Previous year questions with answers in years. Question 2023. Which innovation in evaluation systems provides immediate results after an exam? A. Peer assessment. B. Continuous evaluation. C. Computer-based testing. D. Gamification. Answer. C. Computer-based testing, asked in UGC Net Environmental Science 2023. Question 2022. What is the main advantage of project-based evaluation in environmental science? A. Assesses theoretical knowledge. B. Encourages real-world application of knowledge. C. Focuses only on written exams. D. Requires no feedback. Answer. B. Encourages real-world application of knowledge, asked in UGC Net Environmental Science 2022. Question 2021. What is the key feature of continuous and comprehensive evaluation, CCE? A. One-time exam assessment. B. Focus on practical exams only. C. Ongoing feedback and assessment throughout the year. D. Limited to multiple choice questions. Answer. C. Ongoing feedback and assessment throughout the year, asked in UGC Net Environmental Science 2021. Question 2020. Which technology is used in some evaluations to ensure transparency and security? A. Blockchain. B. Peer assessment. C. Virtual reality. D. Self-assessment. Answer. A. Blockchain. Asked in UGC Net Environmental Science 2020. Question 2019. How does artificial intelligence (AI) aid in educational evaluations? A. By reducing the need for human evaluation entirely. B. By grading exams and assignments automatically. C. By eliminating the need for feedback. D. By increasing exam anxiety. Answer. B. By grading exams and assignments automatically, asked in UGC Net Environmental Science 2019. This lecture on innovations in evaluation systems has been designed to help you understand how modern assessment techniques are changing the landscape of education, especially in the field of environmental science. If you'd like to dive deeper into any specific innovation or if you're ready for the next topic, feel free to ask. You said, research aptitude research, meaning, ChatGPT said. Research aptitude, meaning, process, and importance in academic and professional contexts. Research is a systematic process of inquiry that involves investigation, exploration, and discovery to develop new knowledge or validate existing knowledge in a specific field of study. In the context of higher education, research aptitude is a critical competency for students, researchers, and academicians. It forms the foundation of scholarly inquiry and drives innovation in science, technology, social sciences, and humanities, including disciplines like environmental science. In this lecture, we will explore the meaning of research, the process of research, and its importance in academics, with a specific focus on how these concepts relate to the UGC Net JRF exam preparation. What is research? Research can be defined as a systematic investigation designed to discover, interpret, and revise facts, events, behaviors, or theories. Research is a process that leads to new knowledge or improves the understanding of existing knowledge, making it more reliable and applicable. It is generally driven by curiosity and a desire to address specific questions or solve problems in the real world. Systematic investigation. Research is not random, it follows a specific method or approach, ensuring that it is credible and valid. Discovery or validation. Research either leads to the discovery of something new or confirms the validity of existing information. For instance, in environmental science, research might help uncover new environmental solutions or validate the effectiveness of policies. Problem solving. Research often aims to solve specific problems, such as how to mitigate climate change, conserve biodiversity, or reduce pollution. Types of research. Basic research, fundamental or pure research. This research is driven by curiosity and aims to expand knowledge without a specific practical application. For example, studying the role of microbes in nutrient cycling in ecosystems. Applied research. This type of research focuses on solving specific, practical problems using scientific methods. For example, researching sustainable farming practices to address environmental degradation. Key features of research. Purposeful. It aims at answering a specific question or solving a particular problem. Logical and analytical. Research involves a structured approach to problem solving and relies on logical reasoning. Objective. Research is unbiased and objective, and the findings are based on facts, data, and evidence. Reproducibility. Research findings should be reproducible by other researchers to confirm their reliability. Research process. Steps involved. The research process can vary based on the discipline or the research question, but it generally follows a set of key steps. Identifying the research problem. The first step is to identify a research problem or question. This is the foundation of the research and requires careful consideration of existing literature and gaps in knowledge. Example, in environmental science, a problem could be the impact of urbanization on local biodiversity. Review of literature. A thorough review of existing literature is essential to understand what has already been researched and published in the chosen area. This helps refine the research question and provides a context for the new study. Example, a review of studies on climate change effects in different geographical regions. Formulation of hypothesis. Based on the identified problem in literature review, researchers form a hypothesis or a statement that they aim to test during the research process. Example, a hypothesis could be, increased urbanization leads to a decrease in local species diversity. Research design and methodology. This step involves choosing the research methodology: qualitative, quantitative, or mixed methods, and designing the study. Researchers must decide on the type of data collection methods, surveys, experiments, field observations, etc., and the tools used for analysis. Example, if studying the impact of urbanization on biodiversity, field observations and biodiversity indices may be used. Data collection. Researchers collect data based on the methods outlined in the research design. Data could be quantitative, numerical, or qualitative, descriptive. Example, collecting data on the number of species in urban and rural areas over a defined period. Data analysis. After collecting the data, researchers use statistical tools or qualitative analysis methods to analyze the data and interpret the results. Example, analyzing species population changes using statistical software or comparing biodiversity indices. Conclusion and interpretation. Based on the analysis, researchers draw conclusions. They interpret the findings in the context of the research hypothesis and relate the results to the research question. Example, concluding whether urbanization significantly reduces biodiversity in the studied regions. Report writing and dissemination. The final step is to write a detailed research report or paper, which includes the methodology, data, analysis, findings, and conclusions. The results are then disseminated through academic journals, conferences, or public reports. Example, publishing findings in an academic journal or presenting them at an environmental science conference. Importance of research in academic and professional contexts. 1. Advancement of knowledge. Research is essential for the development of new theories, models, and paradigms in any field, including environmental science. It helps us understand complex phenomena and contributes to the scientific body of knowledge. Research drives innovation and shapes the direction of future studies. Example, research on the impacts of pollution or deforestation leads to the development of new conservation strategies or technologies to mitigate environmental damage. 2. Informed decision-making. Research plays a critical role in providing evidence for informed decision-making. In both academic and professional settings, decisions are often based on empirical evidence generated by research, leading to better outcomes. Example, policymakers use research on climate change to formulate environmental policies or regulations aimed at sustainability and environmental conservation. 3. Critical thinking and problem solving. Research encourages critical thinking and problem-solving skills. By analyzing existing knowledge, identifying gaps, and testing hypotheses, researchers develop solutions to real-world problems. These skills are highly valued in both academic and professional contexts. Example, researchers working on renewable energy solutions use critical thinking to design new technologies that can reduce dependency on fossil fuels. 4. Professional development. Engaging in research activities is an essential part of academic and professional growth. Research exposes individuals to current trends and developments, enhances their analytical skills, and opens avenues for career advancement. Example, graduate students and researchers in environmental science may contribute to publications and conferences, establishing themselves as experts in their fields. Previous year questions with answers in years. Question 2023. What is the first step in the research process? A. Data analysis. B. Identifying the research problem. C. Literature review. D. Writing the research report. Answer. B. Identifying the research problem, asked in UGC NET Environmental Science 2023. Question 2022. Which of the following is the most essential characteristic of research? A. Curiosity. B. Subjectivity. C. Randomness. D. Systematic inquiry. Answer. D. Systematic inquiry, asked in UGC NET Environmental Science 2022. Question 2021. What type of research focuses on solving specific practical problems? A. Basic research. B. Applied research. C. Theoretical research. D. Exploratory research. Answer. B. Applied research. D. Exploratory research. Answer. B. Applied research, asked in UGC NET Environmental Science 2021. Question 2020. Which step of the research process involves collecting information from existing literature? A. Formulation of hypothesis. B. Data collection. C. Literature review. D. Report writing. Answer. C. Literature review, asked in UGC NET Environmental Science 2020. This lecture on research has provided a thorough overview of its meaning, process, and importance, specifically tailored for UGC NET JRF environmental science preparation. If you need further clarification or want to explore other topics, feel free to ask. You said, types. ChatGPT said, types of research. Research is a broad and diverse field that can be categorized in various ways based on its purpose, methodology, and approach. Understanding the different types of research is crucial, especially for UGC NET JRF environmental science preparation, as it helps in identifying the appropriate research strategies for specific problems or areas of study. Below are the primary types of research categorized by different criteria, such as purpose, methodology, and approach. 1. Based on purpose of basic, fundamental, or pure research. Basic research is driven by curiosity and aims to expand knowledge without seeking immediate practical application. It seeks to understand underlying principles or theories in a specific field, often leading to future innovations or applied research. Objective, to gain a deeper understanding of natural phenomena or theoretical aspects. Example, studying the behavior of ecosystems in untouched environments to understand ecological processes. Importance in environmental science. Basic research helps in expanding knowledge on topics like biodiversity, ecology, and climate change without an immediate focus on application. B. Applied research. Applied research focuses on solving specific practical problems using the knowledge derived from basic research. It addresses real-world issues and provides practical solutions. Objective: to solve specific, real-world problems or apply knowledge in practical scenarios. Example: investigating the effects of air pollution in urban areas and proposing mitigation strategies. Importance in environmental science. Applied research is vital for developing solutions to environmental challenges like sustainable resource management, pollution control, and conservation. C. Exploratory research. Exploratory research is conducted when there is little existing knowledge about a topic. It is used to explore new ideas or phenomena and is often the first step in the research process. Objective: to explore a new or unfamiliar subject area and generate ideas for further study. Example: exploring the effects of microplastics on marine life in a new geographical area. Importance in environmental science. It helps identify emerging environmental issues that have not been thoroughly studied, like new forms of pollution or unknown ecological threats. D. Descriptive research. Descriptive research aims to describe the characteristics of a particular phenomenon or group. It does not attempt to explain why things happen but simply outlines what is occurring. Objective: to provide an accurate and detailed description of a phenomenon or event. Example: documenting the species composition and population dynamics in a specific habitat. Importance in environmental science. Descriptive research helps in creating a comprehensive baseline inventory of ecosystems, species, or environmental conditions, which is essential for conservation efforts. 2. Based on methodology of quantitative research. Quantitative research focuses on gathering numerical data and analyzing it using statistical methods. It is often used to test hypotheses or examine relationships between variables. Objective: to quantify data and generalize results from a sample to the population. Example: measuring the concentration of pollutants in different water sources and analyzing the data statistically to identify trends. Importance in environmental science. Quantitative methods are crucial for assessing environmental factors such as air quality, water contamination, and species diversity. B. Qualitative research. Qualitative research focuses on understanding the meanings, experiences, or concepts behind a phenomenon. It involves non-numerical data such as interviews, observations, and textual analysis. Objective: to gain insights into people's experiences, perceptions, and behaviors regarding a phenomenon. Example: conducting interviews with local communities to understand their views on sustainable agriculture practices. Importance in environmental science. Qualitative research is useful for exploring human-environment interactions, policy perceptions, and understanding local knowledge and environmental management. C. Mixed methods research. Mixed methods research combines both quantitative and qualitative research approaches. It allows researchers to use the strengths of both methods to gain a comprehensive understanding of a research problem. Objective: to integrate both numerical data and in-depth insights for a fuller understanding of the issue. Example: using quantitative data to measure air quality and qualitative interviews to understand community perspectives on air pollution. Importance in environmental science. Mixed methods are ideal for studying complex Importance in environmental science. Mixed methods are ideal for studying complex environmental issues that involve both measurable data and human or societal factors. 3. Based on time frame of cross-sectional research. Cross-sectional research collects data at a single point in time. It is often used to analyze the relationships between variables at that specific moment. Objective: to provide a snapshot of a particular situation at a specific time. Example: surveying biodiversity levels in various ecosystems during one field season. Importance in environmental science. Cross-sectional research is useful for assessing the current state of an environmental issue, such as pollution levels or species distribution. B. Longitudinal research. Longitudinal research involves repeated observations or measurements over an extended period. It is used to study changes over time and can establish cause and effect relationships. Objective: to examine changes over time and identify long-term trends. Example: tracking the impact of climate change on species migration over several decades. Importance in environmental science. Longitudinal research helps in understanding the long-term effects of environmental factors, such as deforestation or climate shifts, on ecosystems. 4. Based on data collection techniques. Experimental research. Experimental research involves manipulating variables to observe the effect of one variable on another, often in a controlled environment. It is commonly used to establish causal relationships. Objective: to test hypotheses by manipulating variables under controlled conditions. Example: experimentally assessing the effect of fertilizer types on the growth rate of a specific plant species. Importance in environmental science. Experimental research helps understand ecosystem functions, pollutant effects, and conservation strategies. B. Non-experimental research. Non-experimental research does not involve manipulation of variables. It is used when experiments are impractical or unethical, and often focuses on observation and analysis of existing conditions. Objective: to observe phenomena as they occur naturally, without intervention. Example: observing the habitat preferences of endangered species in the wild. Importance in environmental science. Non-experimental research is essential for studying natural systems and understanding how species or ecosystems function in the real world without external interference. Previous year questions with answers in years. Question 2023. Which type of research focuses on solving practical problems using existing knowledge? A. Basic research. B. Applied research. C. Exploratory research. D. Descriptive research. Answer: B. Applied research, asked in UGC NET Environmental Science 2023. Question 2022. What is the main goal of exploratory research? A. To prove a hypothesis. B. To explore new ideas or phenomena. C. To quantify data. D. To describe a phenomenon. Answer: B. To explore new ideas or phenomena, asked in UGC NET Environmental Science 2022. Question 2021. Which research type involves manipulating variables to observe effects in a controlled environment? A. Descriptive research. B. Experimental research. C. Mixed methods research. D. Non-experimental research. Answer: B. Experimental research, asked in UGC NET Environmental Science 2021. This provided an overview of the various types of research, highlighting their purpose, methodology, and importance, particularly for environmental science studies. By understanding these distinctions, you'll be better prepared for questions related to research types in the UGC NET JRF exam. You said, characteristics. ChatGPT said, characteristics of research. Research is a systematic and structured process aimed at discovering new knowledge, solving problems, or improving existing practices. Understanding the core characteristics of research is essential, especially for the UGC NET JRF Environmental Science exam, as it forms the foundation for conducting credible and valuable studies. Below are the key characteristics of research that define its nature and process. 1. Systematic process. Research follows a methodical approach that involves clearly defined steps. The process includes identifying a problem, reviewing existing literature, formulating hypotheses, collecting data, analyzing results, and drawing conclusions. Every step is carefully planned to ensure that the research is valid and reliable. Example, in environmental science, conducting research on air pollution involves systematic data collection, analysis, and interpretation of results. 2. Objective and purposeful. Research is always conducted with a specific objective in mind. The purpose may vary, from expanding existing knowledge to finding solutions for particular problems. The research objective provides clarity and direction, ensuring that the study remains focused and relevant. Example, the purpose of a study on climate change could be to evaluate its impact on biodiversity, providing meaningful insights for conservation. 3. Empirical. Research is based on empirical evidence derived from observations, experiments, or experiences. This characteristic ensures that research findings are grounded in real-world data rather than mere opinions or assumptions. Example, in environmental science, empirical data might include measurements of water pollution levels or species population counts in different habitats. 4. Analytical and critical. Research is analytical and involves critical thinking. Researchers critically examine data and literature, look for patterns, test hypotheses, and identify potential biases. It requires the ability to assess information from multiple perspectives and make informed decisions based on evidence. Example, analyzing the effects of deforestation on local ecosystems requires a critical examination of multiple variables such as soil quality, species distribution, and water availability. 5. Logical and rational. Research follows a logical sequence, where the conclusions are drawn from well-supported evidence and analysis. It emphasizes reason and clarity in the formulation of hypotheses, data collection, and interpretation of results. A rational approach ensures that findings are coherent and scientifically valid. Example, the research on sustainable farming practices must be based on logical analysis of the benefits versus drawbacks in relation to environmental impact. 6. Replicability. Research must be replicable, meaning that other researchers should be able to repeat the study using the same methodology and obtain similar results. This characteristic enhances the reliability and credibility of research findings. Example, if a study on the effects of plastic waste on marine life is conducted, other researchers should be able to replicate the study in different regions or conditions and confirm the results. 7. Data-driven. Research is heavily dependent on the collection and analysis of data. Whether qualitative or quantitative, data is the backbone of research, supporting hypotheses, theories, and conclusions. Data can be collected through various methods such as surveys, experiments, or field observations. Example, in environmental science, data such as temperature readings, pollution levels, or species populations form the foundation for understanding ecological changes. 8. Iterative. Research is often an iterative process, meaning that it involves cycles of testing, refining, and retesting. Based on initial findings, a study might be revised or expanded to include new variables or data points. Example, a study on ecosystem restoration might require several iterations, as the initial results might not fully capture all ecological variables. 9. Originality. Research strives for originality, meaning it contributes new knowledge, ideas, or methods. While it may build upon existing work, research aims to add value to the field by exploring new avenues or solving previously unaddressed problems. Example, investigating the relationship between urban heat islands and human health could provide original insights into climate adaptation strategies. 10. Ethical. Research must adhere to ethical standards, ensuring that it is conducted with integrity, transparency, and respect for participants, the environment, and society. Ethical research practices include obtaining informed consent, ensuring confidentiality, and minimizing harm to participants or ecosystems. Example, in research related to wildlife conservation, ethical considerations would involve ensuring the humane treatment of animals and minimizing the impact on natural habitats. Importance of these characteristics in UGC NET JRF Environmental Science. Understanding these research characteristics is crucial for several reasons. Designing effective studies. Knowing the systematic, objective, and analytical nature of research helps in designing effective studies for addressing environmental issues, such as pollution control or habitat restoration. Ensuring credibility. The empirical, logical, and ethical aspects ensure that research findings are credible and reliable, which is essential for influencing policy and practices in environmental management. Building a knowledge base. By conducting original and replicable research, researchers contribute to building a robust knowledge base that can be used to tackle future environmental challenges. Previous year questions with answers in years. Question 2023. Which of the following is a key characteristic of research? A. Personal opinion. B. Subjectivity. C. Empirical evidence. D. Speculation. Answer. C. Empirical evidence. Asked in UGC NET Environmental Science 2023. Question 2022. What does the term replicability in research refer to? A. The ability to use the same data. B. The ability to repeat the research and get the same results. C. The analysis of qualitative data. D. The ability to solve the problem. Answer. B. The ability to repeat the research and get the same results. Asked in UGC NET Environmental Science 2022. Question 2021. Research is considered blank when it involves systematic steps to collect data, analyze results, and interpret findings. A. Descriptive. B. Random. C. Logical and rational. D. Intuitive. Answer. C. Logical and rational. Asked in UGC NET Environmental Science 2021. This lecture has outlined the key characteristics of research, which are fundamental for both academic study and real-world application in environmental science. By mastering these characteristics, you will be better equipped to conduct credible and effective research, which is essential for your UGC NET JRF Environmental Science exam. You said. Positivism and post-positivistic approach to research. ChatGPT said. Positivism and post-positivistic approach to research. In the context of research, especially within disciplines such as environmental science, philosophy of science, and social science, understanding the differences between positivism and post-positivism is essential. These approaches provide the underlying frameworks that guide how research is conceptualized, designed, and interpreted. Below is an elaborate explanation of these approaches, tailored to the needs of UGC NET JRF environmental science aspirants, to help in both academic research and preparation for the exam. Positivism. Positivism is a philosophical theory that asserts that only factual knowledge derived from empirical evidence and observable phenomena is valid. The term originates from the work of Auguste Comte, 1798-1850. Positivism and post-positivistic approach to research. In the context of research, especially within disciplines such as environmental science, philosophy of science, and social science, understanding the differences between positivism and post-positivism is essential. These approaches provide the underlying frameworks that guide how research is conceptualized, designed, and interpreted. Below is an elaborate explanation of these approaches, tailored to the needs of UGC NET JRF environmental science aspirants, to help in both academic research and preparation for the exam. Positivism. Positivism is a philosophical theory that asserts that only factual knowledge derived from empirical evidence and observable phenomena is valid. The term originates from the work of Auguste Comte, 1798-1857, who is often regarded as the father of positivism. In positivist research, the emphasis is on objectivity, measurability, and scientific methods to establish general laws of nature. Key features of positivism. Empiricism and observation. Positivism is rooted in the belief that knowledge is derived from sensory experience, i.e., what can be observed, measured, and quantified. Researchers rely on data collection, primarily through experiments or observations, to uncover patterns and laws of nature. Objective reality. Positivists believe in an objective reality that exists independently of the observer. The goal of research is to uncover these universal truths, regardless of the researcher's biases or perspectives. Quantitative research. Positivist research typically employs quantitative methods, such as surveys, experiments, and statistical analysis, to test hypotheses and generate data that can be generalized to broader populations. Hypothesis testing. In positivism, researchers start with a hypothesis, a testable statement, and seek to either confirm or disprove it using empirical evidence. Detachment. The researcher remains detached and neutral during the research process to prevent personal beliefs or biases from influencing the findings. Predictability and generalization. Positivism aims to predict and generalize findings across different settings, believing that the same laws apply universally, whether in the natural world or the social sphere. Example in environmental science. A positivist approach to studying climate change might involve collecting and analyzing temperature data over several years to identify patterns, draw conclusions, and predict future trends. The focus would be on objective data such as temperature measurements, carbon dioxide levels, or ice cap volume. Post-positivism. While positivism has been a foundational approach to research, the post-positivistic approach emerged as a critique and extension of positivism. Post-positivism acknowledges the limitations of positivism, emphasizing that absolute certainty in knowledge is impossible. This approach is often seen as a more philosophically refined and realistic version of positivism. The term, post-positivism, is associated with philosophers like Karl Popper, Thomas Kuhn, and Emer Lakatos, who sought to refine the positivist approach by incorporating elements of uncertainty, subjectivity, and interpretation. Key features of post-positivism. Fallibility of knowledge. Post-positivists argue that knowledge is fallible. Researchers cannot be entirely objective, and absolute certainty cannot be achieved. Knowledge is always subject to revision and refinement based on new evidence. Critical realism. Post-positivism adopts a position called critical realism, which believes that an objective reality exists, but our understanding of it is always incomplete and influenced by our interpretations, contexts, and experiences. Qualitative methods. While post-positivism allows for quantitative methods, it also recognizes the value of qualitative research, such as interviews, case studies, and content analysis, in capturing the complexities of human behavior in the social world. Theory hypothesis. Post-positivism recognizes that researchers enter the research process with preconceived theories or hypotheses that guide their inquiry, and these can evolve throughout the study. Contextual influence. Post-positivists acknowledge that social, cultural, and historical contexts influence how research is conducted and interpreted. This recognition leads to a more flexible and interpretive approach. Constructivist approach. Post-positivism aligns with constructivism, which suggests that knowledge is socially constructed. The researcher's perspective and biases play a role in interpreting data, and findings may vary depending on the context. Subjectivity and reflexivity. Post-positivist researchers recognize the subjectivity in data interpretation and strive for reflexivity, which involves being aware of how their own positions, values, and experiences shape the research process. Key features of post-positivism. Fallibility of knowledge. Post-positivists argue that knowledge is fallible. Researchers cannot be entirely objective, and absolute certainty cannot be achieved. Knowledge is always subject to revision and refinement based on new evidence. Critical realism. Post-positivism adopts a position called critical realism, which believes that an objective reality exists, but our understanding of it is always incomplete and influenced by our interpretations, contexts, and experiences. Qualitative methods. While post-positivism allows for quantitative methods, it also recognizes the value of qualitative research, such as interviews, case studies, and content analysis, in capturing the complexities of human behavior in the social world. Theory and hypothesis. Post-positivism recognizes that researchers enter the research process with preconceived theories or hypotheses that guide their inquiry, and these can evolve throughout the study. Contextual influence. Post-positivists acknowledge that social, cultural, and historical contexts influence how research is conducted and interpreted. This recognition leads to a more flexible and interpretive approach. Constructivist approach. Post-positivism aligns with constructivism, which suggests that knowledge is socially constructed. The researcher's perspective and biases play a role in interpreting data, and findings may vary depending on the context. Subjectivity and reflexivity. Post-positivist researchers recognize the subjectivity in data interpretation and strive for reflexivity, which involves being aware of how their own positions, values, and experiences shape the research process. Example in environmental science. A post-positivist approach to researching deforestation would involve collecting quantitative data on forest cover loss through satellite images and surveys, but also considering qualitative aspects, such as local community experiences, cultural values, and historical context, which influence the causes and impacts of deforestation. Comparison of positivism and post-positivism. Aspect positivism, post-positivism. Nature of knowledge objective, measurable, and universal fallible, socially constructed, context-dependent approach scientific, deterministic critical, interpretive methodology primarily quantitative surveys, experiments both quantitative and qualitative methods allowed reality objective reality exists independently objective reality exists, but is interpreted subjectively researchers role detached, neutral reflexive, acknowledges subjectivity and bias goal discover universal laws and predict phenomena understand complexities and refine theories importance in UGC NET JRF environmental science. Positivism is particularly useful for research in environmental science when the goal is to quantify and predict ecological or environmental trends. For example, determining the impact of pollution on air or water quality. Post-positivism allows for a more nuanced understanding of environmental issues by considering social, economic, and cultural contexts. It is particularly helpful when researching topics like sustainable development, where both quantitative data, such as emissions reduction rates, and qualitative data, such as community participation, are needed. Previous year questions with answers in years. Question 2023. Which of the following is a key difference between positivism and post-positivism? A. Positivism emphasizes subjective interpretations, whereas post-positivism focuses on objective reality. B. Post-positivism embraces the fallibility of knowledge, whereas positivism assumes absolute certainty. C. Positivism only uses qualitative methods, while post-positivism uses quantitative methods. D. Positivism avoids any form of theory, while post-positivism emphasizes theoretical frameworks. Answer. B. Post-positivism embraces the Answer. B. Post-positivism embraces the fallibility of knowledge, whereas positivism assumes absolute certainty. Asked in UGC NET Environmental Science 2023. Question 2022. In which approach is the researcher's subjectivity acknowledged and accounted for during the research process? A. Positivism. B. Post-positivism. C. Realism. D. Pragmatism. Answer. B. Post-positivism. Asked in UGC NET Environmental Science 2022. Question 2021. Which research method is most closely associated with positivism? A. Qualitative interviews. B. Case studies. C. Surveys and experiments. D. Content analysis. Answer. C. Surveys and experiments. Asked in UGC NET Environmental Science 2021. By understanding the positivist and post-positivist approaches to research, you are better equipped to navigate both quantitative and qualitative methodologies in environmental research. This knowledge is crucial for successfully tackling UGC NET JRF environmental science questions, which often test your understanding of research paradigms and methodologies. You said, methods of research. ChatGPT said, methods of research. In the realm of environmental science and research methodology, understanding various research methods is crucial for conducting scientific investigations. These methods form the backbone of any research process, guiding researchers to systematically gather, analyze, and interpret data to answer specific questions. This lecture will provide a detailed breakdown of the different research methods used across disciplines, especially in the context of environmental science, to help you excel in UGC NET JRF environmental science. Types of research methods. Research methods can be broadly classified into two main categories, qualitative and quantitative. These two methods represent fundamentally different approaches to research, each suited to different types of questions and problems. 1. Qualitative research methods. Qualitative research is used when the goal is to explore phenomena in depth and understand the meanings, experiences, or perceptions of people. It is primarily focused on subjective data and provides rich, detailed descriptions that help explain complex, non-quantifiable factors. Key features of qualitative research. Non-numerical data collection, involves interviews, observations, and textual analysis. Exploratory nature, ideal for understanding behaviors, attitudes, or social phenomena. Inductive reasoning, begins with observations, then builds theories or patterns. Focus on context, looks at phenomena in their natural settings. Common qualitative research methods. Interviews, structured, semi-structured, or unstructured interviews are used to gather personal experiences or opinions. Case studies, detailed investigations of a single instance or case, e.g., a specific environmental policy or local ecosystem. Focus groups, group discussions that allow researchers to gain insights into participants' attitudes, beliefs, and experiences. Observational studies, involves observing behaviors or processes in their natural environment. Ethnography, an in-depth exploration of a culture or community, often used in environmental studies to understand the relationship between local communities and natural resources. Example in environmental science, a qualitative study on community-based conservation might involve conducting interviews with local residents to understand how they perceive conservation efforts and how these efforts impact their livelihoods. 2. Quantitative research methods. Quantitative research is more structured and focuses on numerical data. It is used to measure variables and look for patterns or relationships. The goal is to develop generalizable results that can be applied to larger populations. Key features of quantitative research. Numerical data. Data is collected through instruments like surveys, tests, or experiments. Statistical analysis. Data is analyzed using statistical techniques to determine relationships, correlations, or trends. Hypothesis-driven. Typically involves testing hypotheses to confirm or refute theories. Objective approach. Emphasizes objectivity, replicability, and the ability to generalize findings. Common quantitative research methods. Surveys, questionnaires, used to gather data from a large population. These can be structured or unstructured and involve closed-ended questions. Experiments. Controlled studies in which one or more variables are manipulated to observe their effect on other variables. Content analysis. The systematic analysis of content, e.g., text, images, or videos to identify patterns or trends. Longitudinal studies. Involve repeated observations over time to study changes and developments. Example in environmental science. A quantitative study might involve surveying a community to assess the level of knowledge about water pollution and its correlation with the community's water usage practices. The data could then be analyzed statistically to draw conclusions. 3. Mixed methods research. Mixed methods research combines both qualitative and quantitative approaches in a single study to provide a more comprehensive understanding of the research problem. It is particularly useful when the research question requires both numerical data and in-depth exploration of experiences or opinions. Key features of mixed methods research. Integration of both data types. The research uses both quantitative and qualitative data collection and analysis techniques. Sequential or concurrent design. The qualitative and quantitative phases may occur one after the other or at the same time. Comprehensive perspective. It provides a richer, more nuanced understanding of the research question. Common applications in environmental science. Assessing the effectiveness of environmental policies. A study might combine surveys to measure environmental behavior, quantitative, with interviews to understand why certain behaviors exist, qualitative. Community-based environmental management. A researcher may use qualitative interviews with community members and quantitative surveys on resource usage to study the impact of a conservation program. Steps in conducting research. Regardless of the method, all research involves certain fundamental steps. Below is a general overview of these steps. Problem identification. Define the research problem clearly. This step involves identifying a gap in the existing knowledge or an issue that requires investigation. Literature review. Conduct a thorough review of existing literature to understand the current state of knowledge in the field and refine the research problem. Formulation of hypotheses. Develop a hypothesis in quantitative research or research questions in qualitative research that the study will seek to answer. Research design. Choose an appropriate research method, qualitative, quantitative, or mixed methods based on the research questions and objectives. Data collection. Use the selected research methods to collect data. This might involve surveys, interviews, experiments, or observations. Data analysis. Analyze the data using appropriate techniques. For quantitative research, this involves statistical analysis. For qualitative research, this involves thematic or content analysis. Interpretation and conclusion. Draw conclusions from the analyzed data, considering the limitations of the study, and answer the research questions or test the hypotheses. Reporting. Write a report or paper that details the research process, methodology, findings, and implications. Previous year questions with answers in years. Question 2023. Which of the following is a method typically used in qualitative research? A. Surveys. B. Statistical analysis. C. Case studies. D. Experiments. Answer. C. Case studies asked in UGC NET Environmental Science 2023. Question 2022. What is the primary goal of quantitative research? A. To understand the meanings and experiences of individuals. B. To explore subjective experiences. C. To generate numerical data for statistical analysis. D. To analyze cultural context. Answer. C. To generate numerical data for statistical analysis asked in UGC NET Environmental Science 2022. Question 2021. Which research method combines both qualitative and quantitative techniques? A. Experimental research. B. Mixed methods research. C. Descriptive research. D. Survey research. Answer. B. Mixed methods research asked in UGC NET Environmental Science 2021. Question. Teaching support system. Traditional, detailed lecture. In the field of education, teaching support systems are the set of